Welcome back, guys. My name is Dr. AVITECH. In this video, we're going to be solving these 4 problems on beta functions. Now, this is actually questions from University of Benin, apart from number 4, of course. But that's actually easy, but they don't really set it. So I have a problem, and let me say what my problem is. It is a habit that they repeat these very 2 questions. It's a habit, and here is why. I kind of feel like you cannot be giving 300 level student this very equation because this is dx and the function is theta. So these 2 answers you see here are going to be treated as constant. That's my problem with this whole, this whole stuff. That's my problem with it. Because the answer for this very equation, since this is dx, please take note. This and this is not the same. If you notice, it is with respect to theta. But here with respect to x, but there's no x in the expression. So I honestly hope this is a real equation and the lecturers are aware that there's a mistake here and not penalize students who actually solve it the way I'm going to solve it. Because the answer to this will become, to start with, since it's a constant, all you have to do is just attach x to it. So attach x to it. So that's x sine cubed theta cos cubed theta. This is what you're just going to do. And then you put your limit from 0 to pi over 2. But the thing is, if it's from 0 to pi over 2, and this is the only place where x is existing, that's the only place where x is existing, this means that only the pi over 2 will be useful. Because when you put in 0, 0 times everything will give you 0. So the answer to this problem is just pi over 2 sine cubed theta cos cubed theta. That's just the answer. And then how about this very one? How about this very one? If you notice, these 2 are exactly the same. They're exactly the same. The only difference is there's a 3 in front of this one. So since these 2 are exactly the same, they just multiply by 3. That means the answer for this one will become 3 pi over 2. You just have to times this one by 3. Sine cubed theta cos cubed theta. That's the answer for number 1 and 2. That's just how to solve question 1 and to solve question 2. So it's actually easy. But when it's the question number 3, that is now where we then start talking about how to make it look like this one. That's when we then start talking about it. Because now this is now with respect to theta, or theta, with respect to theta. So let us solve this one. So that one is what we have to solve. The integral from 0 to pi over 2 of sine cubed theta cos cubed theta d theta. Now, first of all, here's one thing you need to know. In the standard form, there's a 2 here. There's a 2 here in the standard form. So this means that to solve for this, when there's no 2, you must take the half. In fact, if I want to solve problems on this, I always take the half. I'll just put half here. No matter what number I have, I'll just put half times that very number. Because if you notice, I can just divide both sides here by 2. So if you divide here by 2 and divide here by 2, what you'll be having will then become half of the beta function. Half of the beta function. So I'm going to say half times the beta of, now here's the problem. This time around, this is 2m minus 1. So 2m minus 1 will be equal to this very 3 here. So if 2m minus 1 is equal to 3, that means 2m is equal to 3. If the minus 1 goes over, it becomes plus 1. So this is 2m equal to 4. That means m would have become 4 over 2, which is 2. So this is 2, comma. If you notice, this is also 3. So if you say 2n minus 1 equal to 3, you still have the same answer here. So that's 2 also. So sometimes you just have to be very, very careful. So this is equal to half times, this will be the gamma of 2 times the gamma of 2 divided by the gamma of 2 plus 2. Okay, so this is half times, gamma of 2 is just 1 factorial. Gamma of 2 again, 1 factorial. And then 2 plus 2 is 4. So what is the gamma of 4? Gamma of 4 is 3 factorial. Your minus 1, So gamma of 4 is 3 factorial. So this is 1 over 2 times 1, because 1 factorial times 1 factorial is just 1. 3 factorial is 6, because it's 3 times 2 times 1, so that's 6. So this will just become 1 over what? 12. And that's just the answer to that very question. It's just going to be what? 1 over 12. That's the answer. No more, no less. 1 over 12. Now, for number 4, the integral from 0 to pi over 2 of root tan theta d theta. That's a beautiful one. So here's the first thing we want to do. Remember that from trigonometry, tan is actually sine over cos. So this is actually the integral from 0 to pi over 2 of the root of sine theta divided by cosine of theta d theta. That's the first thing we want to do. Now this is the integral from 0 to pi over 2. Now remember that square root actually means the power of half. So this is sine theta divided by cos theta all to the power of half d theta. Okay, now this is the integral from 0 to pi over 2. Now I can now expand this. This actually means sine theta cosine inverse of theta all to the power of half d theta. That's what it's just going to be. Logically, that's what it's going to be. So this will become integral from 0 to pi over 2. Now let us bring in our half. So this will become sine half theta cosine minus 1 times this is minus half theta d theta. Of course, that's just what it's going to be. So this is what we're going to be having. Or you could even say here, sine half theta cos half. Then if the cos half comes on top, it's going to have a negative power. Now again, remember, whenever I'm dealing with this standard form, I always say half times the beta of, this is half, right? So remember, you're going to say 2m minus 1 is equal to half. So this is 2m equal to half. If this minus 1 comes over, it's going to become plus 1. So this is 2m equal half plus 1 is 3 over 2. Now, divide both sides by 2. That means m would then become 3 over 4. So that's 3 over 4. So this will become the gamma of, where's that guy? 3 over 4. Now, I hope you know why it's 3 over 4. If you put over 1 here, when this 2 times is 2 times 2 is 4. So you must always have 4. Now, for this minus half, if you say, let me do it here. If you say 2n minus 1, 2n minus 1 is equal to minus half. This is 2n equal to minus half plus 1. So this is 2n equal minus half plus 1 is same as just half. So you divide both of them by 2, that means n is 1 over 4. So this is 1 over 4. Okay, so let's write this in terms of gamma. This should be 1 over 2 times the gamma of 3 over 4 times the gamma of 1 over 4 divided by the gamma of 3 over 4 plus 1 over 4. Okay, let's see what this is going to be. Now, we'll be needing the special tables for gamma of 3 over 4. Yeah, we'll be needing the special tables for that. The gamma of 3 over 4. I don't think there's a way to derive that from, because even if you say minus 1, you're going to have a negative answer. So let me find the value of the gamma of 3 over 4. I just remember that I kind of have done something like this before. So the gamma of 3 over 4 is 1.2254. I don't know why I forgot. Yeah, I've done something like that before. 1.2254 times the gamma of 1 over 4. I kind of wrote it here. I've forgotten that I even wrote it here. That's 3.6256 over. Now, if you notice, 3 over 4 plus 1 over 4 is just 1. It's just 1 because when you add up the numerator, 3 plus 1 is 4. Then 4 over 4 is 1. And gamma of 1 is just 1. It's just going to be 1. So what will this become? When you do this, this will become 0.6127 times 3.6256, 2.2214. So that's going to be the answer for that very video, or to that very video. So my name remains Dr. AVITECH. I'm going to see you in the next clip. So the next one is going to be a compendium of advanced problems in gamma and beta functions together. So I'm going to see you in the next one. Bye for now.